This is Mr. Martin. These are the video notes for Pre-Calculus Honors, Section 5.4. We're going to be talking about the sum and difference formulas. So what we've got here is we've got three sets of sum and difference formulas. We've got sum and difference formulas for the cosine function and for the sine function, and also down here for the tangent function. So I'm going to go ahead and go through these sort of quickly, and then eventually we'll talk about the derivation of one of these. We don't really need to talk about the derivation of all of them, but I know sometimes in class you want to do that the cosine of alpha plus beta is equal to the cosine of alpha plus the cosine of beta, but this is not true. Okay, this is not the case. And again, we'll go through the derivation, which is on page 2 of these notes, but for now just know that this is not true and these are the formulas. So if you notice, for cosine of alpha plus beta, we have cosine alpha cosine beta minus sine alpha sine beta. And then for the difference formula here, it's the same thing except it's addition. So cosine ones are opposite of each other. Then we have the sum and difference formulas for the sine function. There are some patterns to these formulas, so if you can remember the patterns, it'll make things a little easier. These are cosines and sines together, and then down here the cosines and sines are mixed, and the sines actually match. So sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And then for subtraction, for the difference formula, we just subtract for those. And keep this sheet handy when you're doing these problems until you memorize them. And then the tangent formulas are a little bit different. They're in fractional form. So tan alpha plus beta is tan alpha plus tan beta over 1 minus the product of the two tangents. And then for minus, it's the same thing except we're just switching these two signs here. So let's move on. Again, we're going to come back to the derivation of formula 2 above, and we're going to move on to applying these formulas. So we have our cofunction identities where cosine of pi over 2 minus theta is the same as sine of theta, and sine of pi over 2 minus theta is the same as cosine theta. So what we're going to do is we're going to use our sum and difference formulas to establish these or verify that these are true. So for the first one, I'm going to let u, actually I'll stay consistent with the variables. I'm going to let alpha be pi over 2, and I'm going to let my beta, in this case, be theta. And same thing over here, alpha is going to be pi over 2. Let's fix that up there, pi over 2, and beta we'll just let be theta. Just a little substitution there. So now when I'm using my sum and difference formulas, this is going to be cosine alpha cosine beta plus sine alpha sine beta. And we'll go ahead and substitute into that in a minute. And then for this one, we're going to have sine alpha cosine beta minus cosine alpha sine beta. So again, I'm just using the formulas from up here, way up here, for the cosine difference formula and the sine difference formula. Alright, so moving back here. So now I'm going to substitute in my pi over 2's and my thetas. So for 3a, I've got cosine pi over 2 cosine theta minus, plus sine pi over 2 sine theta. Right, and we know the cosine at pi over 2, that's the x-coordinate at the top on the unit circle, is going to be 0. So that's 0 times cosine theta plus sine at pi over 2 is 1 times sine theta. And when we simplify, we end up with sine theta. So that one checks. That's what we wanted to get up here, sine theta. And then let's go ahead and do this for 3b. So we've got sine pi over 2 times cosine theta minus cosine pi over 2 sine theta. And again, we know the sine at pi over 2 is 1 times cosine theta minus cosine at pi over 2 is 0 times sine theta. And when we simplify, we just get cosine theta, which again is what we were looking to get up here. Alright, and as usual, if you have any questions, take the time to pause the video and write down your question and ask me. Okay, so let's apply the sum and difference formulas to find the exact value of an angle that's not one of our special angles. So we've got 105 degrees here, and I can actually break up 105 into the sum of two special angles. So I can break it up into 60 degrees plus 45 degrees, and since I really prefer to work in radians, this is going to be the same as pi over 3 plus pi over 4. So now my problem becomes the cosine of pi over 3 plus pi over 4, and I'm going to use my sum formula for cosine. So again, if you need to refer back to it up there, you can. So it's going to be cosine pi over 3 cosine pi over 4 minus sine pi over 3 sine pi over 4, and these are all special angles, so I can start to calculate this. So the cosine at pi over 3 is 1/2. Cosine at pi over 4 is root 2 over 2. Sine at pi over 3 is root 3 over 2. Sine at pi over 4 is root 2 over 2. So I get root 2 over 4 minus root 6 over 4, and then we can write our final answer as root 2 minus root 6 over 4. So this would be our final answer. There's no need to do any more simplifying. Final answer. So this would be the exact value of the cosine of 105 degrees. Now, since many of these problems are using our special angles, a lot of our answers are going to look similar, having root 2's and root 6's. So keep that in mind as you go along. Alright, so let's move on to the next example. We want to find the exact value of the sine of 7 pi over 12. So what we're looking for is we're looking for two numbers that will add up to 7 pi over 12, and we want them to reduce to special angles. So if I have 7 pi over 12, one way we could break that up is 3 pi over 12 plus 4 pi over 12. Now, there's other ways to break up 7. We could have done 1 and 6. We could have done 2 and 5. But when we use 3 and 4, the reason that I like these is because now 3 pi over 12 is going to reduce to pi over 4, and 4 pi over 12 is going to reduce to 3 pi over, pi over 3. Pi over 3. Okay, so now the sine of 7 pi over 12 becomes the sine of pi over 4 plus pi over 3. So that's going to be sine u, which is pi over 4, or alpha, cosine beta, which is pi over 3, plus cosine pi over 4 sine pi over 3. And we know sine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2, plus cosine pi over 4 is root 2 over 2. And that should be a 3. Sorry about that. Hopefully you caught that. It's going to be root 3 over 2. So we get root 2 over 4 plus root 6 over 4, which is just root 2 plus root 6 over 4. And again, you can leave your answer like this. Alright, moving on to the next example. Again, write down any questions. So we want to find the value of the expression without using a calculator. So we've got some stuff on the inside. Let's take a look at that. We've got sine inverse of 1. Okay, so what we want to think is we want to find the angle that has a y coordinate of 1. So what angle has a y coordinate of 1? Okay, and we know the angle that has a y coordinate of 1 is pi over 2. And then we're looking for the cosine inverse of 1. So we want to know what angle has an x coordinate of 1. That's 0 radians. Okay, 0 radians, just so you know that we're talking about an angle. We don't really need the radians. So now we know sine inverse of 1 is pi over 2. Cosine inverse of 1 is 0. So now basically I'm looking at the sine of pi over 2 plus 0, which is just the sine of pi over 2, which is 1. Okay, so we didn't really need to use the sum or difference formulas for this. We could have, you would have gotten the same answer. You know, if you combine the stuff in the parentheses and it happens to be one of our special angles or a quadrant angle, then you're all set. Okay, next example, we're going to use right triangles to evaluate the expression. So what you want to think about here is that I have the cosine of two angles, because this is an angle, I'm going to call it alpha, and this is an angle, I'm going to call it beta. Okay, and whatever those angles are, I've got two triangles, so this is going to be alpha, and I know the cosine of that angle is 3 over 5, so this side's going to be 4. And then I have another triangle where this angle is beta, and I know the sine of that angle is 5 over 13, so that's going to be 5, that's going to be 13, which means that's going to be 12. So I've got the cosine of alpha minus beta, which is the cosine alpha cosine beta plus sine alpha sine beta. So then I'm going to use my two triangles to find all these. Cosine alpha, I come over here, is 3/5. Cosine beta, I come down here, that's 12 over 13. Plus sine alpha, back to the top triangle, sine is 4 over 5. Come down to the bottom triangle for the sine, I've got 5 over 13. Alright, so this is 36 over 65, and this is 20 over 65, which turns out to be 56 over 65. Alright, so that's going to do it for this video. And again, as always, if you have any questions, make sure that you write them down and you ask. And we will see you next time.